we've done a lot of integrals, and we've done a lot of different derivatives at this point in the year, but now we're going to kind of expand our tool belt, or toolbox, and learn about some more different types of equations. So during this next unit, we're going to talk about both logarithms and exponential functions, and we're going to talk about how to deal with the derivatives and the integrals of them. So first we're going to talk about the properties of logarithms. Now we're going to deal almost exclusively with natural log, but most of these properties hold for any logarithm. So first of all, you should know that the natural log of 1 is equal to 0. That's true for any log. Log of 1 is equal to 0, any base at all. Secondly, the natural log of e is equal to 1. Now that is only true for the natural log, because natural log is log base e. So if you plug in the base of any log, the result is 1. But that one is, natural log of e is only 1 for natural log. Okay, the next three we're looking at, though, hold for all logarithms. Okay, first is what's called the product rule for logarithms. This is not to be confused with the product rule for derivatives. But basically what it says is that if you are multiplying two things inside of a natural log, you can split it into two different logarithms by adding them. Okay, there's also one for division, and that says that if you are dividing two things inside of a natural log, then you can split them into two logarithms by subtracting. And the final one says that if you have an exponent that applies to the inside, now two things I want to point out there. It needs to apply to the whole inside, but also only to the inside. Okay, it does not need to apply to the whole natural log, just to what's inside. Then you can actually move it down as a coefficient. Now, if we move this direction, that's called expanding the logarithm. I'm just looking at these three right now. If you move that direction, it's expanding, but you're allowed to go both directions. If you come this direction, it's called condensing. And we are mostly going to be concerned with expanding, but I want to make sure you know that it is possible to do both, and both directions work. This is equals, so that means both directions are valid. So let's look at some examples of this. This should be something you saw in pre-cal. So first, expand the logarithm. Well, we see here we're dividing, and if we look back at our properties, we see that dividing can be changed into subtraction. So I just do the natural log of 10 minus the natural log of 9. Now if you notice on this next one, we have a square root. And nothing was specifically said about square roots or radicals at all previously. But if you remember, a square root can be rewritten as an exponent of 1/2. So using the fifth property we had on that first page, we can move the 1/2 down front as a coefficient. It's up to you if you write this middle part or not. You certainly don't have to write that if you're told to expand, but if it helps you, then that's absolutely fine. Now part C I am going to do in 2 steps, and I would recommend you do in 2 steps just to keep yourself from making any mistakes. So this says the natural log of x squared plus 3 squared over x times the cube root of x squared plus 1. So that's a cube root. That 3 does not go with the x, it's by itself. I would first apply properties 3 and 4. So just so you know what I'm talking about, let's go back here. I would first apply these two. Change multiplication to addition and change division to subtraction. That's the first thing I would do when I'm expanding. So I would write this as the natural log of x squared plus 3 squared minus the natural log of x minus the natural log of the cube root of x squared plus 1. And I am going to go ahead and change that cube root to a power of 1/3. Okay, now you may be asking yourself a question. This is something that throws a lot of people off. Why is this a negative? Because aren't we multiplying the x and the cube root of x squared plus 1? Well, we are multiplying the two of them, but you need to look at the fraction as a whole. When you look back at the fraction as a whole, both x and the cube root of x squared plus 1 are on the bottom of the fraction, meaning we are ultimately dividing by both of them. Now, if you wanted, you could actually put parentheses around them and then do a plus, because that would imply that you are subtracting or dividing the entire piece but that these two are multiplied together inside that. So that is valid. You can write it that way if you want to, but personally I would recommend you just remember anything on top of the fraction is positive, anything on the bottom of the fraction is negative. But we're not quite done. We need to do something about the exponents. So now that we've done properties 3 and 4, I would do 5. But we're not finished. We still need to do the, I think I already said that, sorry. Had to pause the cough. So now we're going to apply that fifth property, so we bring all the exponents down as coefficients. So we get 2 times the natural log of x squared plus 3 minus the natural log of x minus 1/3 natural log of x squared plus 1. And that is complete. That is completely expanded for our logarithm. So again, I would recommend you do these in 2 steps. Do the division and the multiplication properties first, and then after that, in the second step, take care of moving the exponents down as coefficients. Now I just want to look at one example going the other direction. And this one says condense into a single logarithm. So we're using the same properties, but we're going the opposite direction. Instead of expanding, we're condensing it down into 1. So since we're going the opposite direction, I would do things in the reverse order. I would go ahead and take care of the coefficients becoming exponents first. So that's going to look like this. Natural log of x to the 1/2. You're welcome to write that as the square root of x if you prefer. Natural log of x plus 1 cubed, and then there's no change here because there's no coefficient other than 1. Alright, now I would apply the rule that allows me to change addition to multiplication and subtraction to division. So my final answer is going to look like x to the 1/2 times x plus 1 cubed, all divided by x cubed minus 4. So now we've gone the other direction. We've condensed this into a single logarithm. So the properties do allow you to go either direction. I want you to practice both, but just so you know, the one that's more important is the expanding, and you'll see why soon.